All right, let's jump right in. I want you to try something for me. Try to imagine nothing. I mean, absolute nothing. No air, no light, not a single particle, just emptiness. Here's the catch, though. You can't actually do it. And that's because it turns out that empty space, even the most perfect vacuum we can imagine, is absolutely packed with, well, with something. And figuring out what that something is, it's going to completely change the way you look at reality.
Go ahead, do it right now if you can. Put your hand on a table or your desk or whatever's in front of you. Feel that? That solid, unyielding surface? Seems pretty real, doesn't it? Your hand stops, the table stops. It feels like the most obvious thing in the world. But what if I told you that what you're feeling right now is a complete and total illusion?
That's right, you heard me. Your hand is not touching that table. The atoms that make up your hand have never, ever made physical contact with the atoms of that table. In fact, you have never truly touched anything in your entire life. So, what in the world is going on here?
To get our heads around this, we have to zoom way, way down to the level of atoms. See, that feeling of touch isn't about two things bumping into each other at all. It's about a fundamental force of the universe creating an invisible shield, an invisible cushion that gives us the illusion of solid matter. Every single atom, yours and the table's, has a fuzzy outer edge made of these tiny, negatively charged particles called electrons. And these electrons generate an invisible force field all around themselves. It's called the electromagnetic field. And this field, my friends, is the star of our show today. So let's break down this illusion. What you think is happening is pretty simple, right? The atoms in your hand are literally bumping up against the atoms in the table. But that's not it at all. What's really going on is that the electron fields around your atoms are getting super, super close to the electron fields of the table. And since they're both negatively charged, what do like charges do? They repel. They push away from each other hard. And that powerful push, that electromagnetic repulsion, that's what your brain registers as the feeling of touch.
And the consequence of this is just, it's wild. It means you're not actually sitting on your chair. You are hovering a tiny, tiny fraction of an atom's width above it, suspended entirely by this invisible cushion of force. You've literally been floating your entire life and never even knew it.
But this idea, it goes so much deeper than just how we feel things. It forces us to completely rethink what the stuff of the universe is actually made of.
So, what's in that space between all the atoms? It's not empty. It's filled with these force fields, stretching out from every particle, overlapping, interacting, like an invisible fabric. And these fields aren't just some clever math trick. They're real. They carry energy. They exert force. They're the cosmic glue holding all of us together.
Okay, but let's push this. What if we could create a perfect vacuum? I mean, we suck out all the atoms, all the particles, and all the fields connected to them. What's left then? That has to be true nothingness, right? Well, nope, not even close.
This is one of the most fundamental rules of quantum mechanics. Thanks to a little thing called the uncertainty principle, no patch of space can ever have exactly zero energy. Not even for a moment. Nature it hates a true vacuum. So space itself is forced to constantly do something. It has to fizz and bubble with energy.
So how does space pull this off? Well, you can think of it like a quantum loan. For just a split second, the vacuum borrows a tiny bit of energy from nowhere. And with that loan, poof, a particle and its antimatter twin pop into existence. But here's the deal. They only get to exist for a fleeting, impossibly short moment. Then, bam, they smash into each other, annihilate, and pay back the energy loan. As long as it all happens fast enough, the universe kind of looks the other way.
And this isn't some weird, rare event. This is happening in every single cubic centimeter of space all around you, right now, billions and billions of times a second. The vacuum isn't some quiet, peaceful void. It's the busiest, most chaotic, most energetic place in the entire universe.
Now, I know this sounds like something out of science fiction, but we have actual hard proof that this vacuum energy is real and that it has real-world effects. It's a brilliant experiment called the Casimir effect, and it's the smoking gun. Here's how it works. You take two perfectly smooth, uncharged metal plates. You put them inside a perfect vacuum, and you move them incredibly close together. I mean, almost touching. You get rid of every other force you can think of. Logically, absolutely nothing should happen. But something does. The plates actually start to move.
So, why do they move? Well, think of all those virtual particles as being like waves in an ocean. In the big, open space outside the plates, waves of all sizes can pop up. But in that tiny, tiny gap between the plates, only the very smallest waves can fit.
And here's the key. This means you get more quantum activity, more virtual particles, more waves, pushing on the outside of the plates than you do on the inside. This difference creates a tiny but real measurable pressure from empty space itself. The vacuum is literally pushing the plates together. It's not empty, it pushes.
Okay, let's take a breath and put all of this together. The illusion of touch, the fields between atoms, the buzzing energy of the vacuum. It all points to one absolutely profound revelation about what reality actually is.
This is the final, huge shift in perspective. We love to think of the universe as being made of little solid bits, particles, that are just rattling around inside a big, empty box called space. But the reality is so much stranger, and frankly, so much cooler than that.
So that old idea? It's intuitive, but it's just wrong. The new reality, the one proven by quantum field theory, is that these fundamental fields are everything. What we call a particle, like an electron, it isn't a thing at all. It's just a ripple, a little vibration, a little knot of energy in its underlying field.
And this is the final takeaway that might just blow your mind. Those fields, they're everywhere, which means you, made of particles, are really just a collection of complicated, stable ripples in the very same fields that make up the empty space right next to you. Matter is just a more excited, more organized version of the same fundamental stuff as the vacuum.
So I want to leave you with a final thought to chew on. These fields don't have edges. They stretch out through all of space-time, connecting everything to everything else. You are just a complex pattern, a stable vibration in these universal fields. So the question isn't, what's an empty space? The real question is, if you're part of the same field as everything else, where do you stop and the rest of the universe begin?